by the envelope theorem, right, every individual, the value that they lose is exactly equal to their income, right? Because they pay the tax on their current income. And so what we get is when we take the derivative of this, every person is going to lose a value which is equal to their income. That's what they pay in taxes. And then what do we gain? Well, people gain the average income because that's what we tax away. But that average income also falls because of the labor supply elasticity, right? So it's going to be the average income times 1 minus the tax rate, because that's what you're currently earning on the average income, times the amount by which the average income falls, which is the average elasticity over 1 minus the tax. Right? So that just comes from taking the derivative here. Every person loses I, and then what do they gain? They gain, if the tax rate goes up, they gain the average income, but then that average income falls, and so you use the product rule and you take the derivative here, and that's all multiplied by the welfare weight that we put on someone. What's the welfare weight? It's 1 over their income. So if someone's poorer, we put more weight on them getting money. If someone's richer, we put less weight on them getting money. Right? And so this all becomes 1 minus the tax rate times the average elasticity over 1 minus the tax rate times the product of the average income and the average welfare weight that we put on someone. That comes out of this term, right? Because you've got the average income and the average welfare weight. And then minus the income over the welfare weight times the welfare weight. So this is the average product of the income and the welfare weight. Right? Okay. And one thing to notice is we've got this income bar times welfare weight bar minus the bar of the two of them, right? And you'll probably remember from your statistics class that the difference between the expectation of the product and the product of the expectations is the covariance, right? And so we can just write this term sigma as a normalized covariance between income and your welfare weight. So normalized by the average income and the average welfare weight. And basically what that measures, the negative of that covariance measures, is sort of the degree of inequality, right? If there's a lot of inequality, then the people earning higher incomes are going to have much lower welfare weights. If people are differing a lot, right, then this covariance is going to be very large. If this covariance is very small, that means there's very little inequality, right? Because imagine that everyone had the same income, well, this would clearly be 0, right, because there would be no variance. So we can view this as a very simple and natural measure of the inequality in society. Okay. So then, what is the optimal income tax? We'll just rearrange this formula. And we get that, okay, so just divide, we want to set this equal to 0, right? This was the derivative. Divide through by I bar. Subtract this off and divide through by I bar, and you get that 1 minus the tax rate times the average elasticity over 1 minus the tax rate is equal to sigma. Is that right? It doesn't seem right. What is going on? Okay, I'm going to have to work this out. I'm pretty sure this is right, but somehow it doesn't seem right now. But anyway, so you have the optimal tax rate is this covariance thing times the average elasticity plus this covariance thing. And that basically says that, so first of all, sigma has to always be greater than 0 because the wealthy always have a lower welfare weight than the less well-off do, right? And as sigma increases, that's going to increase the optimal tax rate. As epsilon increases, that's going to decrease the optimal tax rate, right? If you increase epsilon, that increases the denominator, decreasing the whole expression. If sigma increases, that increases the whole expression. And this captures the basic equity versus efficiency trade-off that we were talking about. Stieg, can you explain why that captures the equity versus efficiency trade-off?
I'm not quite sure.
Does anyone else want to try to explain how it captures the equity versus efficiency trade-off? Everett, yeah?
I mean, I think, well, I mean, if sigma is greater for the wealthy, because like they're less income, less. I don't know, I'm guessing because like they're less affected by a decrease in income.
Yeah.
That would probably mean that you could probably tax them more, and
Yeah.
then you can give it to somebody else who is like more affected by a change in income.
Well, so the key thing isn't the difference in elasticities. David, do you want to?
Well, I mean, if you're looking at the average elasticity, that's like really, really large in a given society, then
Yep.
it seems like the optimal tax rate should not be very high because you have a big change if
Yeah.
you have a high tax rate, and that's reflected in the formula because
Yeah.
if you have a large denominator, then it pushes your optimal tax rate lower.
Yeah. Yeah, so that's exactly, so sigma is exactly a measure of inequality, right? The more unequal society is, the bigger sigma is, right? So that's exactly what we said. It was the variance, or it's a covariance of the welfare weights with the income, right? And the elasticity is the efficiency cost, right? It's how much people reduce their earnings when you increase taxes. And so what this is saying is the more inequality there is, the higher taxes we should have, the more response people make to an increase in tax, the less tax we should have, right? And that's exactly the equity efficiency trade-off, right? And you know what, I think I have time. I'm just going to go through and make sure I've got this formula right for you guys. So we've got right, and that's equal to 0. And rearranging that, we have that I bar W bar minus I W bar over I bar W bar is equal to the tax average elasticity over 1 minus the tax. This is what I defined as sigma of T. Note sigma depends on T because as we tax more, there's going to be less inequality, right? So as taxes increase, the inequality falls, as well as the other term rising. This is going to be equal to the tax times the elasticity bar over 1 minus the tax. So we get 1 minus T is equal to tax times the elasticity bar through sigma. Yeah, the formula is correct. So it's sigma is equal to T times elasticity bar plus sigma. So that's right. The problem was that this equation is wrong. Sorry about that. There shouldn't be that one there. Okay.
But the T star is right?
The T star is correct. Okay. So, this is a very simple formalization of the equity efficiency trade-off. So notice, imagine that the inequality in our society is enormous, right? Sigma is very, very large, except when the taxes are very close to 1. So we're like redistributing everything. Then the tax rate is going to be very close to 1, right? Because then this thing will be very close to 1 for anything, you know, any tax rate at all below 1. On the other hand, imagine that the elasticity goes to 0, right? Then also the tax rate goes to 1. So if there's no response, we also redistribute everything. And the opposite thing happens. So if we have no inequality initially, we're not going to want to do any tax. If the elasticity is very large, we're not going to want to do very much tax. So the more inequality there is and the less elasticity, the higher the optimal tax rate is. So this model covers sort of most Americans, right? This linear tax is a good way of thinking about sort of what the average tax that people in the population should pay is. But President Obama has recently proposed putting a surcharge on people earning a lot of money, so earning over $1 million. And when taxing the rich, the calculation is actually a little bit different. Because if you think about it, the welfare weight that we put on anyone earning $1 million or above is almost nothing, right? So under log utility, the welfare weight that you put on someone who earns $1 million is about 1/20th of the welfare weight you put on an average person, a median person in the population, right? And so the calculation simplifies down to just figuring out how we can get the maximum revenue out of those people, right? We don't want to tax them too much because then they won't work as hard, but we don't really care about them having the money relative to the rest of the population. So that makes things even simpler because we don't need to worry about all these welfare weights. We can just say, what tax would we put on these guys that would maximize the total amount of revenue we earn? It's just like a monopoly problem, right? So let's call T sub 10 to the 6th the tax on incomes above $1 million. If we let I bar 10 to the 6th be the average income of those who earn over $1 million, then we can again come up with the two effects that we had before. Victor, you wanna explain what those two effects are or how they play out here? If we raise the tax, what are the two effects that have on the amount that we earn?
Well, I mean, like you're going to get more, but it's going to be, it could decrease the way to work.
Yeah. And so those two things have sort of offsetting
Yeah,
effects, right?
So you'll get more money, but you'll have less people in the work.
Yeah, so mechanically, it just increases our revenues from the person who's earning an income I by an amount I minus $1 million, right? Because if they're earning $2 million, we're gonna, if we increase tax 1%, we get 0.01 times their income minus $1 million, right? On the other hand, for everyone who's earning over $1 million, they're going to reduce the amount that they work, and that's going to cause their income to fall by epsilon bar of I over 1 minus T sub 10 to the 6%, right? And that reduces the taxes that we earn, because we were taxing those guys at that part of their income at T sub 10 to the 6, so that's going to reduce it by the tax rate times their income times epsilon bar over 1 minus T.
Are you using the same epsilon bar here?
At that income, so this is an income-specific epsilon bar. So we have epsilon bar with no income inside of it means the overall population average, we're weighted by income, whereas this is the income-specific average.